when you have run, when it has an infinite loop. When it has an infinite loop, it normally behaves that way. So in today's lesson, we are going to learn about iteration. And the first thing which I will expect you to know is the definition of iteration. What does it mean by the term iteration? So iteration, it just means that repetitive nature. This means you are going to write a code which it will allow repetitive nature. So according to what I've written there, iteration is a process of executing the same section of a code over and over again. So the process of executing the same section of a code over and over again is what we call iteration or looping. And in this chapter, we are going to look at two types. We have got two different statements that describes iteration. And one of that statement is a while statement, and the second one is a for statement. So we'll start by giving out the example of a while statement. Now, for example, if you want to write uh, a section of a code over and over again, we normally use the while or for statement. For example, I want to write a program which can write, I want to write a program which it will execute numbers up to 1000 in an interval of 100, starting from an initial point 100. So I will set my initial point 100, and I say count is equals to 100. So this means this code will start counting from 100. Then now I will now introduce now iterative function, and in this case it is a while function. So I'll say while count is less or is equals to 1000. So it means it is going to count up to 1000. And I told you, you see, while count is less or is equals to 1000. In our last chapter, I told you it is a condition, and a condition always ends with a full colon. So you will follow it. After writing a condition, you have to follow it with a block. And a block, I told you, is what now your programmer is expecting now the program to execute. You say now print count. So it will print count. And then you see in my last line, I'm saying count plus is equals to 100. It means now you want this count to be in intervals of 100. For example, if it starts now counting from an initial where we have initialized to it at 100, the next value will be 200, 300, 400, up to when now it will reach 1000. So that means then those value will be repeatedly being displayed until it reaches the limit which we have set, which is 1000. So what helps us to do that, that section of our code to be executed over and over again is what we call iteration. And one function which we normally use in iteration is the while function. And I've given you the example of while function. So when I run this section of this code, you see it will display from 100 because I had said count is equals to 100. That is the initial, I initialized my counter. Then I said while count is less or is equals to 1000, it means it will only count up to 1000. Then the last line of a code, I said count plus is equals to 100. This means now I'm setting the intervals which I'm expecting count to be displayed. And this is just the flowchart diagram that explains this code above there. The second thing, we can use the same flow, and you can use the same loop function where we are using now while. We are using while, and we have we are making a program that can be able to sum values. We are making now a program that can be able to sum values. So you see there, I'm initializing my loop. I'm saying end is equals to 0. So a loop must start at 0. And then there is a second point here. I'm saying sum is equals to 0. Now, if you are doing the sum of anything, I'm making this program only to accept sum of a number starting from 0. Then you see here, I'm writing print, enter numbers to sum. Negative numbers ends the list. So I'm making this program in such a way when the program will encounter a negative number, it will exit the loop. So I'm starting now my loop. I say while entry is greater or is equals to 0. So this means this program will only accept values from 0 onwards. Anything which is less than 0, it means it is a negative number, and it will force the program to exit the loop. So you see, after I've written while entry is greater or is equals to 0, that is my condition. And the condition has to be followed by a block. And I told you a block is what the program is expected to execute. So I'll say entry is equals to eval input. I told you that eval function is used where the programmer wants to enter either a float or an int value. Then you see I've written if entry is greater or is equals to 0. If entry is greater or is equals to 0, what are you expecting now the program to execute? Because now, if now entry is greater or is equals to 0, this means the program will ask the programmer the second value. Because if it is greater or is equals to 0, it means it is not a negative number. And when it is not a negative number, this means it will not exit the loop. So if it is greater or is equals to 0, I'm instructing now my program to do summation. That is why you see here in this code, I'm writing sum plus is equals to entry. Then the program will print the summation of all numbers which are greater, which is equal to or greater than 0, and it displays the results. And when you want now to exit the loop, you have to enter a negative number, because this negative number is the one now which it will allow the programmer to exit the loop. So when I run this code, sorry. Yes, when I run this code this way, it will ask me for a number. When I enter a positive number such as 45 and I press enter, you see the program, it will ask me for another number. When I enter another number such as 78 and I press enter, it will pop up that space. That means it is asking for another number. But when I enter a negative number such as -7, it will exit the loop. And before it exits the loop, it will do the summation of 45 and 78, and it will give me 123. So this program here, I've made it using the while statement, and while statement is used in iteration because it allows that repetitive nature of a section of a code. Then the other thing we are going to learn is definite and indefinite loop. So what I want you to know, in definite loop, a programmer determines the number of iterations that a loop performs. In definite loop, a programmer determines the number of iterations that a loop performs. But in indefinite loop, in the cases of indefinite loop, a programmer cannot determine the number of iterations that a loop performs. So we'll start by giving you out an example of a definite loop. A definite loop is where a programmer determines the number of iterations that a loop performs. But in the case of indefinite loop, is where a programmer has got no ability to determine the number of iterations that a loop performs. For example, here, I'm setting my number to be 1. So this means that my loop will start from number 1. So that is why I'm setting my n to be 1. Then I'm using the while, because I've told you while is the statement which is one of the statement which is normally used in iteration. So I say while n is less or is equals to 15. So this means my loop, my iteration will only go up to 15. So this means it is a definite loop because I, as a programmer, have determined the number of iterations that these loops perform, and I've set it to 15. So that's why I'm saying while n is less or is equals to 15. That is my condition. Then I'm telling my program to print n. And how am I expecting the program to print n? I want the program to print n to have the intervals of 1. This is why I'm saying n plus is equals to 1. N plus is equals to 1. This means I want from one value to another to have the intervals of 1. When it counts, for example, from 1, 2, 3, 4, 5, it has those intervals of 1. So when I run this, you will see it will give me 15, it will give me 15 iterations. This loop has got 15 iterations. So how have I determined the number of this iteration? Because I've set here the number 15. If I could have set here the number like 10, it will give me 10 iterations. So it means a definite loop is a loop where a programmer determines the number of iterations that the loop performs. But in the cases of indefinite loop, a programmer has got no ability to determine the number of iteration that a loop performs. The second example, you see here, I've set my initial number, n is equals to 1. Then now in this program, I'm making it to be dynamic so that each and every time you don't come here and put 10, 15, or what have you. So I'm setting this program now to be dynamic. I'm saying stop. When I'm saying stop, this is where now I'm expecting my loop to stop after a certain iteration. So this means it is a definite loop because I'm setting this loop to stop after a certain number of iteration. So I'm saying stop is equals to int input. So this line, it will allow the programmer to enter the number of iteration that he wants or she wants the loop to perform. Then you say while n is less or equal to stop. Stop is the number that you will have entered here. You will have entered here. Print n. And then you want this n to have intervals of 1. For example, if the stops value you have entered 20, it will count 1, 2, 3 up to 20, having intervals of 1. So when I run, and I enter here a number such as 13, this means I'm determining that this loop will undergo 13 iterations. When I press enter, you see it has counted for me 1, 2, 3 up to 13. So in summary, for definite loop, a programmer can determine the number of iterations. Now in indefinite loop, this is where a programmer cannot determine the number of iterations. You can enter numbers to infinite times. So for example, when I want to make this, in this program, I've used the indefinite loop. Indefinite loop is where now a programmer cannot determine the number of iterations. You can enter as many as possible iterations. So for example, here I'm saying done is equals to false. Then it is just to initialize my loop. Then I'm saying while done, while not done, that is my condition. entry eval. It means now I'm allowing this program to accept either an int or a float number. So I say if entry is equals to 999. So if, for example, a programmer enters entry is equals to 999, what should the program execute? If so, if he enters 999, I'm making this program to exit the loop. But if he enters a number which is not 999, the program will continue to accept values until he or she enters a number which is 999. That is why I'm saying if entry is equals to 999, done is equals to true. This done is equals to true. It means now he or she can exit the loop. Else, print entry. If it enters any number which is not 999, that number will be printed. But if he enters a number which is 999, that number, the loop will be exited. So if I run this, you will see, for example, I enter 4. You see when I press enter, it gives me another space so that I can enter more numbers. When I enter 56, it still accepts and it gives me another bar. When I enter 76, it still accepts. So this means a programmer, you cannot determine the number of um, entries or the number of iterations that this program can accommodate. For example, yes.
So why are the numbers appearing 2 times? Like 4 is appearing twice, 56, 76. Is there any condition up here that is dictating that?
There is that condition that is dictating that. So the condition which is dictating that, it is where I've written here, entry is equals to eval, isn't it? So when I will enter the number, entry is equals to eval, it means it accepts either a float or an int. And now I've come here, I've said if entry is equals to 999, done true. It means now, at first, when I will enter this 4, the program will try to interpret. If it gets it is not 999, it will print it. So the first 4 is the interpretation. The second 4, it has now already interpreted, and now it prints it.
Okay.
Yes. Now I've told you now where you see I've entered 4, it has interpreted it and it has printed it. The same way for 56 and 76. This number are not equal to 999. But when I will enter 999, this program has been made in such a way it will now exit the loop. So when I will enter 999, it will now cater for this. If entry is equals to 999, done true. It means now it will exit. But if entry is not 999, it will be catered for under the else statement. It will be printed. So when I will enter 999, you will see it will exit the loop. And you see now the loop has been exited. And how will you know that the loop has been exited? This star sign which was there, it is no longer there, but it shows 6. Then we go for the second type, which we normally use to execute this loop statements or iteration. It is for statement. Now, we normally use for statement the same way we have used the while statement and if statement. Now, this for statement in looping, we normally combine it with range. Now, the first example we are going to give here, you see it is normally written like this. For example, you have a list, and this list you have decided maybe to call it Levi Ruth, or Yvonne. So in my list, I've decided to call it N. You can decide to call it anything that you want, for so long as it is an identifier or a variable. So for example, I say if N in range 1 to 11. Now, you need to note this. Python, when it counts a range, when you see 1 to 11, that means you want to print from 1 up to 10. It normally assumes that last value. So that means you want to print a range from 1 up to 10. If you want to print 1 up to 10, you will write 1 to 11. If you want to print 1 to 20, you will write 1 to 21. That is how Python normally do. So when you see here, I've said for n in range 1 to 11, you see I've ended with a full colon. Then I say now print n. When now I want to print this n, I run, you will see it will display for me a range of numbers from 1, 2, 3 up to 10. If I could have wanted to 9, I will say 1 to 10. I'll say 1 to 10. You see it will have printed for me the values 1 up to 9. Now, I've told you this n, you can just enter anything. For example, even you can enter your name this way. For example, for me, if I enter my name and here I come, I say Levi, it will just give the same thing. It will just give the same thing. So when I run, uh, you see it gives me 1 to 9. So that n is just the name of your range. It's just the name, not your range. It is just the name of your list. It is just the name of your list. You can call it in different ways. So what you can see, you have seen this for n. Let me change it to be n so that I can use it for teaching. For n in range, after writing it for n in range, then I've written 1 to 10. You see I've ended it with a full colon. That means it is a condition. And I've told you, after you have written your condition, it has to be followed by a block. And that block must be intended. So my block is print. I want what should be executed. I want now that list n to be printed. That's why now you see as written print n. Further examples on the same. For example, now you have been given a range of numbers. You have been given a range. Now you want to count these numbers in descending order, starting from 23. And then it has an interval of 3 in reducing order.
Is it 23 or 21?
Yeah, 21. Uh, uh, let me use that 23 because I decided with it. For example, you have been given, you want to count this number in descending order. Descending order, it means now from the largest to the smallest. And it has a reducing factor of 3. How will you do it when you are using looping in Python programming? So you will say for n in range, then the number which you want your program to start with, you want it to start from 23. Then it comes all the way to 0. Then you see here I've put -3. So this means it is the difference now. When it is 23, I want the next number to be printed to be 20, 17 in that order. So when I run this code, you will see it will print for me from 23, 20, 17, 14, then 11, 8, 5, 2, up to 2, because I'd set my my final limit to be at 0. So you see from 2, 1 up to 0, it doesn't have the difference of 3. So it won't print. Let me set it to be -1. You see?
Wait, before you proceed, Levi.
Yes.
Why are these numbers not printed vertically? I mean, why not they're not appearing like the ones that we've already seen? Is there anything that you've done?
Yeah, there is
Did-
anything that I've done.
Oh, what is that?
There is something that I've done.
Mm.
In the first one, it printed vertically, isn't it?
Yes.
Yeah, so it printed vertically because I wrote my print function in just default form. But in this one, you see here the print, I just wrote print n, isn't it?
Yes.
But here, I taught you some different forms of controlling the print function. Here, I've not just written print n. I've
And
written print n,
print
comma,
and
then quotation mark, comma, then end quotation mark. Did you remember?
remind me.
Yeah, so
So
if now, if in this case, I will write this way, I want you to get the difference.
mm,
When I write now this way, you will see the difference, and I remove this quotation
and
mark and a comma. Let me remove this quotation mark and a comma, and you will see another difference, how it will be printed. Now, when I run, are you seeing the difference?
oh yes.
Yeah, those numbers are conjoined, but they are horizontal, isn't it?
Yeah.
But they are conjoined because I've removed this quotation mark. You remember this quotation mark when you are learning in our, I think, chapter 3, it is under the sep function. It is a separator. So because here
Yeah.
there was a quotation mark, this number was separated. And
Uh-huh.
here I have removed that quotation mark, so the numbers, the values are not separated anymore.
Okay.
Now I want now to use the same example, and I print now the third one. In the third one, I want to remove both ends, and I remove the quotation that way. So you see,
So that will be vertical.
you
Yeah.
see when I print, it will be vertical.
Okay.
Yes. Now
Okay.
the other example, you can use the for statement, this for type of a loop, to do now your summation, to do your summation. For example, now I want to do a summation of a number in between 10 to 100. That means it will do a summation from 10 up to 99, because I told you if you say 10 to 100 in Python programming, when you are using a for loop, it will not go up to 100, it will go up to 99. So I'm initializing my sum to start at 0. Now I say for I in range, then my range is 10 to 100. I want now sum. So you see I'm writing sum, then plus is equals to I. I want, this means I want the sum of my list, which is I. Then after it gets the sum, I want my program to print the sum. So when I will run this program, it will do the summation of all numbers from 10 up to 99. So for you to get it clearly, let me use a small number, which you can just sum even on your side. So Ruth, if I can ask, for example, I write the range is 1, 5, isn't it?
Yeah.
What does it mean?
So the sum will be 1 added to 2 to 3 to 4.
To 4, isn't it?
Yeah.
So when you add 1, 2, 3, and 4, what is the result?
To 10.
It is 10.
Yeah.
And if I run this, is it giving 10?
Yeah.
Yeah, it is
Yes.
giving 10. So it means for statement in iteration, it can also be used for summation. And you see it has only added up to 1, 2, 3, and 4. It has assumed the last one, the fifth. So it means the range when you are given 1 to 4, 1 to 5, it will only take up to 4. The same when you are given 1 to 6, it will only take up to 5, and you will get 15. Further examples. Now, these are some further example. I have taught you how to do for the descending, isn't it? Because you saw how it was counting from 23 all the way up to 0. Now, I want to teach you how to do for the ascending. So I'll just copy the same thing. This one. Let me copy the upper one. Now, this was for the descending. I want to teach you how to do for the ascending. For the ascending, it is just the same thing. Now, for the ascending, I want to do the same thing. And ascending, it means now it starts from the smallest to the largest, isn't it?
Yeah.
Now, we'll start with now 0. 0 will be here where we have 23. And then where we have 0, we put 23, isn't it? Then where we add -3, we put now +3. We put +3. That means now it is ascending. It will be having a difference of 3, ascending that way. So when I run this code, you see it will start from 0, 3, 6, 9, 12, that way to up to 21. So it will assume 23. Why? Because another difference of 3, when you add to 21, you will get 24, isn't it? So it means it will reach only up to 21.
So again, that means that even if the difference from the second last number to the last number
Yes.
is how do I put it? Oh, hold on. Now, if the difference between 21 and 23 was to be like, if we had 2 here, were we to write 23 or we still were to ignore it?
If we have 2.
For example, if we have 2, wait, don't run fast.
Yes.
Okay, yeah. It's okay.
If you have 2,
wait.
you will see now the difference. It will start from 2, 4, 6. It will only reach up to 22.
So there is no way we're going to include the last number in the range, right? Even
Now,
if
you want to include the last number, you can go with its factor. You can go with 1.
Yeah, say 1, yeah.
Yeah. When you go with 1, I'm seeing
Still.
also it has assumed the
Yeah.
last number. Yeah. So this means the program, it will automatically assume the last number because
no matter what.
Now, you know, this 23, it doesn't mean it is the last number from this program. It means now that list has got 23 numbers.
Yeah.
Are you getting me? It has got 23 numbers. And since it has got 23 numbers, and you know Python starts counting from 0. You see it has counted from 0.
And what if we had 1 as the first number?
1 as the first number.
Let's see that.
It will still go up to 22.
Okay.
Yeah.
Okay.
Yeah, so it means that last number, when you are going in ascending order, it will be assumed the same way you saw when you are going in descending order. Just look also in descending order. For example, we put here 23 and we put here 1, isn't it? We put here 1 and we want it to be reducing in an order of 1, 1, 1. You will see this one, it will be assumed. You
Oh,
see
yeah.
that the 1 will be assumed. It will only reach up to 2.
Yeah.
So it is the same way when we have this 1 here, 1, 23. Now this is for ascending order, 23, and we remove the negative. The last number in 23 will be assumed.
Okay.
Yeah. So this one, it is for ascending. It is well covered. Then this one I've taught you now is when now you want from numbers from 1 to 9. You will write it 1 to 10. Because this 10 is, we have seen it is normally assumed, isn't it?
Yeah.
Then the same way, when you want to print a range, you just write range 10. It means it will print from 0 to 9. For example, when I copy paste here, this way, and I just write inside here, I just write 10. It will print for me from 1 to 9. Or if I want from, it will print for me from 0 to 9. Or if I just write 11, it will print for me 0 to 10, that way. Then another example, this one, yeah, this one is the ascending also, which I've covered. It is ascending by the difference of 2, 2. Then maybe you want a range from -5. You want a range -5, 5. It will print for you from -5 up to 4.
Oh.
Are you getting it?
Yeah.
Then a range of 1, 2, it will just print for you 1. Then a range of 1, 1, it won't display anything. So you will just pass through all those things which I've mentioned there, and you practice on it through the codes, the way I've been making the codes here. And those codes, it must have the for loop, your list in a range. If you have decided to call your list n, r, any variable, it will do. Now after that, we'll go to nested loop. The same way we dealt with those what do you call the nested if statements. Also in loop, we have got the one which is nested. And what does it mean by nested? We saw in nested if, it is where if is followed by another if, else is followed by another else, or elif is followed by another elif. So in this case, you will see after the for loop, it will be followed by another if statement. For example, here, we want to make a multiplication table of 10 by 10. So the first thing which we have learned from chapter 1, it is the print function. This means you want to display. So you'll say print 1 up to 10. Then this print, you see something like a barbed wire. I've just put that plus sign and dash, dash, dash. That means it is just, that is the way I want now my my columns to be separated to rows. Then I'm now using the for loop. You see for row in range. So you have seen, I want to make a 10 by 10 multiplication table. So if you want to make a 10 by 10 multiplication table, when you are making that row, you will say for row in range. So I told you if you want to print from 1 to 10 in Python, you will say 1 to 11, isn't it? Then you put that full colon. Now, I'm going now to apply now my first if statement. You see, when you are making a multiplication table of 10 by 10, if you take 1 multiply by 10, you will get 10. And if you take now the highest, 10 multiplied by 10, you'll get 100. So you have to make two statements which it will cater for both 10 and 100. So the first statement I'm saying, if row is less than 10, what should now Python print? What should it print? So it has to print the value of those rows. Then now, where I want you to be very keen, it is where now we have these other four. The first four has covered the concept in rows. Now the second four will be covering now the concept in columns. So you see here for column in range 1 to 10, this means it is taking care from 1 up to 10. That is why I've written here for column in range 1 to 11. So I want now this program to be getting now the product of row and column, So the first statement I'm feeding this loop is if product is less than 100. If product is less than 100, I'm instructing my loop to print. Then you see it has been followed by another if statement. What if it is less than 10? You see now this, we have got two if statement. We have got two if statement within the for loop. This is what we call the nested loop. If has been followed another if within the loop, the for loop. So when I will run, you will see it will display for me a 10 by 10 multiplication table. What does it mean by 10 by 10 multiplication table? It has got 10 columns and it has got 10 rows. 10 columns and 10 rows. That is a 10 by 10 multiplication table. And what else us to get this 10 by 10 multiplication table is now the idea of loop, nested loops. It is the idea of nested loop because you have seen if has followed each other within the for statement. Now, this is a program which can only make a 10 by 10 multiplication table. What if now you want to be dynamic? You want to make such a program that can make 1 by 1, 5 by 5, 20 by 20. You will now, if you want to make such a dynamic program of which can give a multiplication table of different dimension, is where now you have to set now the maximum. You have to set the maximum. This max, it means now number of rows or columns. You will just follow the same procedure as the way we have made this first one. But the difference now between the first one and the second one is that the first one is only fixed to make a 10 by 10 multiplication table. But in the second one, it is dynamic. It can make 10 by 10, 5 by 5 by just changing the value of max. For example, I've set this value of max to be 20. When I run this program, it will give me a 20 by 20 multiplication table. It will give me a 20 by 20 multiplication table. What if now I want to get a 10 by 10? I will just come here where I have max and I change it to 10. When I will change it to 10 and I run, you see it has given me 10 by 10. What if I want 5 by 5? I will come just here and change from 10 and give it 5. When I run this code, it will give me a 5 by 5. So what I want you to get is nested loop can be applied when you want to make a multiplication table. And the first one is a fixed, only a multiplication table of 10 by 10. The second one is dynamic, where you want to make a multiplication table of different dimensions. Now, the other thing we're going to cover is abnormal loop termination. Now, there are some loops which it will continue running. It will continue running unless you break them. And how are you going to break them in Python programming? There is what we call the break statement. We normally use the inbuilt break function in Python so that we can terminate. So this means that program has not stopped according to its wish, but you have forced it to stop. So what has helped you to stop it? Because you have used an inbuilt break function. So for example, I want to make this program where now I'm initializing my loop. I set my entry to be 0 and my sum also to be 0. Then now I'm requesting from the user to enter numbers to sum. Negative numbers enters the list. So this program, it means now, in this case, a negative number, it will enter the list. A negative number will end the list. But now, because I'm using the break function, it means if be able to do that by using the break statement. Now, for example, yes, I don't know if you can see my screen.
No.
Because I've had on my side the meeting is being recorded.
I think you have been thrown out of the meeting.
Okay. So this means now I've said while true, that is my condition, entry is equals to eval. It means the program is going to accept either a float or an int. Then I say now my first statement, if entry is less than 0, that is now my first, my other now condition within my first if condition. If entry is less than 0, now, if entry is less than 0, this means it is a negative number. It is a negative number. So I will break. I will break. So I will break. What does it mean by breaking? It means now I will do an abnormal termination to exit this loop. But if it is not less than 0, it means each and every number that I have entered, it will be summed and give the results. But if it is less than 0, it will exit the loop. So when I run and I enter a number such as -6, it will exit the loop. It will exit the loop. And you have seen it has exited the loop, and it has given me sum is 0. Because now it has given me sum is 0 because when you enter a negative number, it won't do summation. But whenever you enter a positive number, it will do summation of all the numbers until where now you will enter a negative number. For example, now I enter 78. You see it has given me another line, 89. It has given me 56 that way. But when I will enter -7, it will exit the loop and it will do the summation of 78, 89, and 56 and give me 223. Then another thing is the yes. Yeah, another thing is the continuous statement. In that one, you saw that whenever I enter the -6, because I'd used the break statement, it will exit the loop. But in this case, when you use the continuous statement, when you enter a negative number, it will not exit the loop. What it will just do, it will just ignore that negative number. but it will not exit the loop. Now, when you want to use a continuous statement, what I'm saying, when I enter that -6, it will not exit the loop. It is different from
Oh,
this break
give me a
statement.
minute, Levi.
Yes.
So in the very first one, the one you said that end with negative number. What if you had another negative number?
No, you will not be in a position to have another negative number, because whenever this program will detect a negative number, it will exit the loop.
Okay.
Yeah, whenever, because you are using the break statement.
Okay.
Now, in this second example, is the one which will allow you to have as many as possible negative number, because now
Oh,
you are
okay.
using the continuous statement.
Got you.
Yeah, now when you are using the continuous statement, it will not exit the loop. Now, you see here, I'm setting my sum to be 0. Then I say done, false. Then now I'm starting my condition. While not done, what should the program execute? So I'm making my program. If while not done, I say value is equals to evil. And as I've been telling you, when value is equals to evil, it means it will accept either an evil, a float or an int. Enter a positive integer. 999 quits. So this program, it will allow me to enter any positive integer, be it negative or positive. But whenever I will enter 999, it is the one which will exit. It is not the same as the first one, where whenever I enter the negative number, it exits. This one now I've set it, whenever I will enter 999, it will exit. So I say if value is less than 0, it will just print that value, but this value will not be summed. It will be ignored. But if value is not equal to 999, if value is not equal to 999, this value will be tallied and its results will be printed. But if value is equals to 999, it will cause the loop to exit. It will cause the loop to exit. Now, let's see. I've said now, if value is a negative, which means it is less than 0, it will just print that value and it will be ignored. For example, when I enter now -7, it will print -7 and it will be ignored. When I enter another value such as -9, it will print it and it will be ignored. When I enter now 67, it will print it now, but it will be tallied. This means it will be tallied. When I enter 87, it will be printed and it will be tallied. When I enter another negative, such as -5, it will be printed, but it will be ignored. Now, I want to exit this loop. I will use the last condition. If value is equals to 999, it exits the loop. So if value is equals to 999, it will exit the loop, but it will print the summation of all numbers which are greater than 0. This means they are positive numbers, but ignored any number which is less than 0. This means they are negative number. So when I enter 999, I will exit the loop. And after exiting the loop, you see it has tallied 67 and 84, and it has given me 154, but it has assumed -9, -7, and -5. So that is why how we use the continuous statement. The break statement, when you enter a negative, it will exit the loop. But in the continuous statement, when you enter a negative, it won't exit the loop. It will just be printed, but it will not be tallied. That is a different way of executing this program in cell 31. So in this cell, it is just a different way of executing the same. For example, here, I can just enter the same thing. I entered -7. It was printed, but it was not tallied. That means it was ignored. When I enter 67, this means it will be tallied. When I enter 87, it will be tallied. And when I want to exit, I will enter 999 and I will exit this loop. I will enter 199 and I will exit the loop. Why am I getting a different thing? -7, 967. Yes, let me try to enter the same thing as the one which I got. -7, -9. Okay. Then 67, 87, 67, 87, and then -5, then 999. No, this one is not the same as the first one, because you see in this one we got 154, and in this one we are getting 133. So I'm making ignored print values. Yes, I will check to see why am I getting the difference. I was expecting to get the same results. So it means, okay, yeah, I'm getting the same different results, because I think in the first one I used the continuous statement, but here you see I've not used the continuous statement. Yeah, that might be the reason. I'll check. Yeah, that is how different it is
But
now.
again, let me interject. I'm sorry. In the first one, we have 67 and 87.
Yes.
They're the only ones that have been tallied.
Yes.
And then they're giving us the sum as 133.
Yeah, in the first one, it is only 67 and 87 that has been tallied, isn't it?
Yes. And the sum is
But
154, which is correct.
which is correct.
And then
But
the second one,
in the second one, I think this program has been made where everything now has been tallied.
okay.
Yeah, everything has been tallied.
So even the negative ones that have been ignored here have been tallied in the sum.
Yeah, in this second one, even the negative has been tallied, because when you take 9 plus 7 is 16, plus 5 is 21, isn't it?
Yeah.
So when you take 154 minus
Minus
21, you get
yeah.
133.
33. Okay.
Yeah. So this means now it is just giving the difference when you use the continuous statement and when you fail to use the continuous statement. You see, when we have used the continuous statement, all the negatives has been ignored. But when we have failed to use the continuous statement, the negatives has not been ignored. Yeah, they have been tallied. Now, the other thing is about infinite loop. And this is the thing which has caused my other notebook fail to load. And when you get such a scenario, you will just know that you have run an infinite loop. So infinite loop, this is a type of a loop that it takes forever to run. You can start to run your notebook, but it can take even up to 10,000 years. It will just continue running. This is the behavior of an infinite loop. And it is normally applicable in websites. So, for example, what I just want you to get is the definition. It is a type of a loop that takes so long time to run until a programmer interrupts it. So you have to interrupt it for it to stop running, or else it will just continue running. For example, now, when I run this, you will see now, and sometimes these loops are not good. Sometimes it can even cause your notebook to hang. It can even cause your notebook to hang. So you see, it will just continue running until now I interrupt. And how are you going to interrupt it? In Python programming, we normally go here where it has been written kernel, and you press interrupt. You press interrupt. So when you press interrupt, you see now it has finished. It has finished running. It has finished running because you have pressed interrupt. I think you have seen. But for my case, I don't want this notebook again to hang. So let me just comment everything. That is the reason why my first notebook was failing to open. It is because of infinite loop. So the only thing which I will want you people to get from there, it is an infinite loop. It will take forever to run until you interrupt it. Until you interrupt it. For the cases of me not making this one to run forever, allow me to comment each and everything, because it might cost me also this notebook. Now, examples of infinite loops. How will you know that a loop is an infinite? For example, yeah, let me set my n. There is something which I think it has changed from my other notebook. Yvonne, were you trying to change something, say, in this notebook?
No, I haven't touched it.
Okay.
Okay.
So when let me set my n to be 10. Let me say n is equals to 10. Then I say factor. Let's say my factor, I say it to be a number. My factor, let me say my factor to be 10. And I try to run. This is an example of an infinite loop. When I run, you see it will just give me 10. It will just give me 10. What if now I try to take a number such as 1 to be my factor? You see it has given me now my factors to be 1 and 2. It has given me my factors to be 1 and 2. And when it has given me my factors to be 1 and 2, look here, you see there is a star sign. There is a star sign. When you see this star sign, when you see this star sign, it means it is running an infinite loop. This means it is running an infinite loop, and it might take forever to run. It might take forever to run. So what will you do for you to avoid that? For you to avoid that, you will come and interrupt that cell. You press it there and interrupt. And when it interrupts and you see that it has given you a keyboard error, keyboard interrupt error, that means that was an infinite loop and it could have taken forever to run. It could have taken forever to run. So what has caused it to be an infinite loop? You see, I've written my n is equals to 10. Then I want to get the factors. Factor is equals to 1. I have set my factor is equals to 1, which is less than n. So I'm trying to make my loop using while statement. I say while factor is less or is equals to 10, is equals to n. That is my condition. Then what should it follow? You see now the loop now is being followed by if statement. I'm saying if n, this percentage sign, I taught you in our first lesson, the percentage sign means modulus, and modulus in mathematics is to look for a remainder. So it means if n remainder factor is equals to 0, what should it do? I'm making my program to print now factor. So what is making this program to be an infinite loop? You see this factor here, the last factor in the last line, it is within the if statement. It is within the if statement. So when it is within the if statement, when I will try to run, it will run forever. It will run forever. But if I could have aligned this factor with if statement, I would have changed it. I would have changed it, and it will no longer be an infinite loop. So for example, now, when I will want to change it now from an infinite loop, what I will do, I'll just come here and make sure I align the factor with if. When I will align this factor with if, you see it has just run and given me the factors of number 10 are 1, 2, 5, and 10. You see it has just run properly. But now
Where? Oh, yeah. Okay. I was asking
but
where are the factors because I had not seen them.
yes, but when now I try to put this factor within now the if statement, it will run forever because it has changed it to an infinite loop. It has changed it to an infinite loop. When I put a factor such as 1, it will just run forever. So for me uh, to avoid it, because when I want it to give me factors which are more than 1, it means it will run forever, as you can see. For me to avoid it, I will have to change this loop either to a definite or indefinite loop. And for me to do so, this factor has to be aligned with if statement. Or the other way, I don't put here 1. I don't put here 1, but I put 10 so that it can just give me one factor. So if I will set it to give me only one factor, it will run. But whenever I will want it to give me more than one factor, it won't run because yeah, it now becomes an infinite loop. So this is what I've just shown you. This is when now you want to change it. Let me set in this code side. I'd forgotten to set 10, then factor is equals to 1. So in this one, it is what I've just shown you above, where now this factor is aligned with if statement. It will just give you those factors because now you would have changed it either to you would have changed it to a definite or indefinite loop. But when this factor is aligned with the last with the print function, it changes it to an infinite loop, which causes it to run forever, which causes it to run forever. Now, another example, it is here. It is here. This juncture here. When it will be this way and I put 1 and I put a value such as 1, it will run forever. And this is the thing which it is making this Jupyter notebook to hang. And it tells me it has crashed because the codes are trying to load forever. And when it loads that way forever, this is just a problem of an infinite loop. That is why you will realize in chapter 7, it has got a lot of infinite loops. So you will see I will be writing at least 3 lines of code. Then I close that Jupyter notebook. Then I use the other one to write the other codes because in that chapter, it has got a lot of infinite loop. If you just try to write more than even 5 lines of codes, that Jupyter notebook will not run at all. It will keep on crashing. So that is why I advise you when you will be passing through, maybe when you will come out of here and you want to practice as a data scientist or a software engineer, try as much as possible to avoid those infinite loops. It normally makes your Jupyter notebook to hang. For example, in this one, when I will say the factor is 10, it will just give me properly. It will just give me properly. But now when I will change it and say the factor is 1, you will see now it will start misbehaving. This Jupyter notebook, it will run forever, and it might even cause my Jupyter notebook to start hanging. It might cause it to start hanging. So it will run forever until I come here and I interrupt. Until I come here and I interrupt. And even after interrupting, you see it takes a lot of time to respond. So for you to avoid, normally I encourage you not to get used to run these infinite loops, because it will only be used by somebody who wants to venture into cybersecurity or software engineer. Because when you want to check a threat, or when you want to check a website, we normally use, you have to use a lot of infinite loops, because this infinite loops is the one which will be checking the system 24 hours per day, 7 days per week, 3 years, 10 years. So you have to use infinite loop. Then this one is just, I think now it is the last one, because it is now time. These are some more examples of infinite loop. It is just some more example of infinite loop. You will practice on your own. You'll practice it on your own. So the other thing, which I'll just touch on it next week in nutshell, before we move on to chapter 6, it is just example of iteration. It will just take less than 20 minutes in our next week classes. Examples of iteration. The first one is computing square root. That is an example of iteration. I will elaborate it widely next week. Then drawing a tree. That is another example of iteration. Then prime factors. So let me run so that you can see how it does. For example, I want to find a square root. This program has been made using iteration. It has not been made using square root function. So when I enter a number such as 1, it will approximate for me, and it gives me it is 9.00 something. Then when I want to draw a tree, maybe I want to draw a tree which has height 10. That way, I will just enter my height, and it gives me that tree. The second approach, and I want maybe a tree of height 7. It is the same thing. Then another application of iteration is when you want to compute and print prime numbers. When you want to compute and print prime numbers, for example, you want only prime numbers up to 100. So it will compute for you. And when the programmer wants to insist on a proper input, when you want to insist on a proper input, for example, you have been given a range from the program wants you to enter values from 0 to 10, and maybe you enter -6. So the program will keep on insisting by displaying a space for you to enter the correct number which is within the range. When you enter another number such as maybe 90, it will keep on insisting, because 90 is not within the range of 0 to 10. But when you enter a number which is within 0 to 10, like 6, that way, the program will exit the loop, and it tells you that it took you 3 tries to enter a valid number, because at the first try, you enter -6, which is outside the range. The second try, you enter 90, which is outside the range. But now the third try, you entered 6, which is within the range. So the program will just tell you it took you 3 tries to enter a valid number. That is the end of our lesson today, unless there is any question. Ruth, do you have any question?
No, I don't have.
Okay.
Yeah, but I'll go through the notes and maybe reach out if I have a question.
Yeah, you will go through the notebook, then you will reach out. But what I insist, avoid as much as possible to run those infinite loops.
Okay.
Yeah, it will make your Jupyter notebook to hang. And you saw how it has given me an headache today to open.
Yeah.
Yeah, because I remembered during the yesterday class, I ran those infinite loops.
Okay.
Yes. Yvonne, I don't know if you have got any compliment.
I will say thank you for the class. Thank you, Ruth, for attending the class. Yes, it was okay and amazing.
Okay, thank you as well. Thank you, Levi, as well.
Okay, thank you a lot. Amos was not able to attend today. He told me that he has been caught up somewhere by some issues. And also, I've realized also Dr. Robert also has sent me a message. He has told me that he has been busy. So he is also requesting if I can have makeup classes with him. So that is it. And also, yeah, that is it. So don't feel lonely, Ruth.
It's okay. I'm good.
Yes.
Okay.
Thank you a lot. Allow me now to retire.
It's okay. You go to bed. Thank you.
Okay. Thank you a lot.
Mhm.
Yeah.